Okay guys, so I'm going to go ahead and briefly go over the solutions to the quiz. For number 1, it is A, and for the reason for that, the limit of h of x as x approaches -3 from the left. If I look at this, this is coming in from the left, h of 3 equals to 1, but also h of -3 is also 1 because it has that point there. Number 2, the limit of h of x as x approaches infinity equals to -6. So as I approach positive infinity, going this direction, going to positive infinity, I keep going up, okay? But then here I hit an asymptote point, so I got to keep going from this point here and keep moving to the right. But notice how my graph is going down, and then now hitting a horizontal asymptote at -6. So that's why A is the answer. Going on, which of the following, let me go ahead and blow this up a little bit right here. Which of the following limits does not exist? Okay, those are good questions to have. Does not exist, and it is E, okay, 1 and 3. If you go back to the graph, okay, the limit of h of x as x approaches 7 does not exist, and the limit of h of x as x approaches -3 does not exist because you have discontinuity points there. Okay, so look at it at h approaching 7 and look at it at h approaching -3, and you see that there is either a hole or there's a split graph where the left and the right limit do not match. So the answer is E for this one. For number 3, which of the following statements is or are true? For number 3, it is C, 2 and 3 only. The limit of g of x as x approaches -2 from the left, so I have to use this equation here from the left. And if I plug in -2 into here, obviously I will get -1 over e squared. And the limit of g of x does not exist as x approaches -2 because these two limits do not match up, obviously, here. That's the reason why the left and the right do not match up. So you see here, these inequalities show me I have a left function, and I have a right function here. When I say left and right, left limit function, I have a right limit function here. For number 4 is going to be A. Simply plugging in the value, I believe, of pi over 6. And so if I plug in that value there, I get square root of 3 over pi. For number 5, it is B. So again, plugging in the value of x equal to 3. Now, I'm going to get 0 on the bottom. So wait a minute, I can't have that. So what we have to do is we have to multiply this by something called the conjugate. So this would look like this. And so the top will be rationalized, the bottom will be rationalized, and I no longer will have a 0 at the bottom. Okay, so the answer will be 1/4. So kind of remember this back in your Algebra 2 and from your pre-cal days. If I have square roots on top and bottom functions in rational functions, I'm going to multiply by something called the conjugate, which means that you see that there's a subtraction sign between the irrational and rational number here. I'm going to put a plus instead and get rid of the square root in the top. Moving on to number 6. On number 6 here, the answer is D. I think this one pretty much was a very self-explanatory one. Show that f of c is defined, but also the limit of f of x exists but does not equal f of c. And obviously part D shows me those two values. Number 7 is going to be B. And if this one here might look a little strange to you, I have the limit of the square root of 3 times, what is the function of f of x as x approaches 2? Well, that's going to be 2. right here. Okay? So that means as x approaches 2, so therefore that's the limit of x approaches 2 is the square root of 6. Okay? Moving on to the free response. The free response, okay, find the value of the limit of f of x. It should show your work, and obviously for you guys what you had to do was you just plug in the value of 2. Now it's coming in from the left, so I have to use this function, x squared plus 2 times the absolute value of x. When I put in the value of x approaching negative 2, this gives me the value of 8. Okay. For part B, now I'm looking at g of x. So what is g of x? The limit of g of x as x approaches 3. So now I'm using the other function to the right. That's g of x. Remember, you have a quadratic, break it apart. So you should have gotten the first off is 2x plus 1 times x minus 3 over x plus 3 times x minus 3. And you can cancel these out right here. So after plugging in your value of x equals to 3, you get 7 over 6. For part C, g of 3 is undefined. Okay, so, and the limit of g of x approaches 3 is 7 over 6. Therefore, g of 3 does not equal to the limit as x approaches 3. Okay, so, and explain your reason. So this does not equal to our actual value. So this does not equal to g of 3. So in order for the limit of f(x) to exist for part C, what two limits must equal? Find the values. Then obviously the left limit must equal to the right limit. So you have to show your work there. I believe from the left it equals 8, and from the right it's going to equal to 14. Let me double check my math here, but I believe so. So again, the left limit must equal to the limit from the right. So okay, so I know that in this part you have a very innocuous situation going on here. So you already know that the value from the left is 8, and you have to figure out what is the value of A. And now remember, we're going to approach this at -2. Okay, so I can plug in the values of this. And for this to equal to each other, A must equal to 14. So then I plug it in into the piecewise function on the very top, all the way over here. Okay? And you will have the equation that helps them to equal to each other. All right, for the very last part, this has to deal with drawing a graph. That may be a little bit cumbersome, but this is something what you should have had. You have an asymptote at -2. Your function from the left, you have a definition point at 2, -4. And then you have a hole at 2, 3. And then you have this graph that goes right through it. Okay, so I hope that helps you out, guys, with this in total. I'll go ahead and put this on YouTube. You'll find this on YouTube, and hopefully you guys can take a look and see how you guys did this.